Hello and welcome to CS264. This is lecture 14 and this is lesson 2. And in this lesson I'm going to continue talking about solid OOP development. And as before, and you may remember in our last lesson, we talked about the single responsibility principle. We started with a basic badly designed program, to do with shapes and calculating the total area of shapes. And I modified this a little bit so that we had some compliance with this SRP. We created the shape class, and we had the area calculation in the shape class, and then we also had an area calculator, and we also produced an output formatter. Okay, so we had lots of good things, so that lots of classes were each doing one task, really. So they're responsible for one task, and that was nice. But at the time I mentioned that it still wasn't particularly good, because a lot of the time we were in violation of this open closed principle, OCP. And what does this tell us? This principle tells us that a software module, or class in our case here, is open for extension and closed for modification. So really what this tells us is that if we want to add additional functionality, we need to be able to extend classes in order to be able to do this. We shouldn't be making changes to the class. So when the class is done and works, we need to hold that class. We could essentially, like in Java, we mark it as final. So you can't make any change. You won't be doing anything else with this class, really. But any modification really has to be done by way of creating an extension to that class. So if we look, for example, at the real core problem here, so this is an issue where we had this enumeration, and every time we wanted to create a new shape type, we had to update this enumeration, and then when we had to calculate the types of various, we had to figure out what type it was, and then do this work here. And the real big problem was the getArea method that sat within our existing shape class. Okay. Now we did change things a little bit here, but we still after we did the SRP, but we still continue to have this section here, which needs to be changed. Okay, needs to be modified. So it's open for modification. We have to modify in a way. We can't fix this issue by just extensions, given the current setup. So we need to change the way we do things. So what we do is we create a shape class hierarchy, and you know this already, of course. And we started with the bad one, so you could see the point and the purpose of having this. So we want to create this class hierarchy that are open for extension and closed for modification. And that means that in order to extend the functionality of the application, we need to ensure that we don't change the existing code. We just add new code. So we're going to introduce this getArea method in the base class. And we had this already, of course, in the base class. And then, but this time we're just going to change it to be an abstract method that tells us all the child classes need to implement this. Shape will be an abstract class, of course, as well. So that's, an abstract class would be one that contains an abstract method. We're still going to retain this double width instance variable in here, because it's a useful thing to have for this particular exercise. It's not good, but we may change that a little bit later, but depending on some of the other principles that we have to look at, LSP, ISP, or DIP. We may or may not, or we may want to change it because it's just better. So the shape class here specifies an interface method, and it retains the width instance variable. So that's what's happening here. Essentially, it's describing how these shapes should be. Okay, so we create a new public class called square, and it inherits from shape. And because we have this abstract method here in terms of getArea, now this square class is responsible for calculating its own area. Okay, here it is, returns area, and we can create a new instance of a square shape. And you'll notice as well that I made a protected double width here. I made this protected so it tells us that class shape and this variable width, instance variable width, will be available to shape and also to its children or child classes. Because this is abstract, we can't just create a shape class. Okay, shape objects. So that's nice. We can only create square, circles, and equilateral triangles. So that's very nice to have that as well. So that's just the beauty of having these abstract classes and abstract methods. So we have this, each of these child classes, square, circle, and equilateral triangle, each work on their own area calculation. They're not reliant on the square. Oh, sorry, I'm not reliant on the shape class. So really what we've done here is we have now closed this for modification and we have opened it for extension. Same here. This does this. These are closed and everything should be fine here. We don't need to do much, but if we need to do some work or increase the modification, we can add it here and it's not going to be have too much of an impact. Okay, so it's lovely. So now every shape looks after its own area calculation. However, if the area calculator, while it's doing a great job in terms of SRP, it also breaks ORP because it needs to change as the previous example when a new shape was added. So in order to update this class, we have to use the final version from the previous one, and we'll do that now. So here we have our shapes. So our area calculator was slightly different. Let's have a look at what it looked like previously. Is it? No, it's actually, no, it's pretty good. It's pretty good. So it did earlier. So the work that we did earlier meant that it was pretty good now. So, but we slightly changed. Did we change it slightly? Let me see here. Calculate shape. No, it was fine. So this was actually pretty good. So this one was pretty good, because we made that change earlier in terms of so sometimes doing the work for the SRP, we introduce some design elements that also mean it meets with the OCP. So originally it didn't work, but now it does, and it actually happened when we went for the SRP. So looking at these in this order is a really, really good idea. Our output formatter, that doesn't change at all. So now we have a program, a new program. So we have something similar to last time, you'll see, but this time we're creating a list of shapes. And here we have a new square, a list of shapes that contains a new square, a new circle, a new square, and an equilateral triangle. And if we go back to this one here, you can see we had to specify the kind of shape with the shape here, with the shape class. We had to have the shape type, and just, it was clunky. It didn't look good. It wasn't nice. This is much neater, and it works just fine. So we can calculate the total area using the static method by calling it as before. This was the better option, or of course using the area formatter, which I prefer and I'd like you to use, of course. So let's save this. Let's run a terminal. Have a new terminal here, and we'll go into our OCP directory, and it should run as expected the same way as before. So the programs all work the same way, but they just aren't as nice. So they're much nicer. So they don't have the errors that we had last time. I'll just make a few small program changes here as I work away through this, for output purposes. And yeah, so that really looks really well. So let's have a look at our final program. So our original program. Let's get rid of this terminal now. So here was the original program here, and the area was here. That's the main part we wanted to change. Our total area is pretty much the same, but we moved that. And if you were to look at the .NET example, you'll see that they had a very different way of doing this in terms of their organization. The one I based it on, this example here, it's a really good example, but I just changed it slightly. So it would deal with various enumerations and the like, and it worked from there. Okay, and their design or the solution's a little bit different. It handles with interfaces, but I want to do interfaces a little bit later, so I'll come back to that in a later lesson. Okay? But we have just by moving this method here into a separate class, even though we were really focusing on the single responsibility principle here, our work looked pretty good, in terms of this one here, in terms of OCP. Okay, so when we moved it into its new, class here, an area calculator class, it actually worked out really nicely for us, as we can see here. Yep, output formatter class and area calculator class. Really nice, really neat. So all classes are doing the job that they want to do because they're obeying SRP, and now they're all OCP as well. Okay, so that's not too bad. Okay. So I'm very happy with this. The next example that we're going to look at, I expect, will be the Liskov substitution principle, and we'll talk about that in the next lesson. Thank you very much for watching.